Hi everybody! Today we talk about the Bohr model. Before we start, one short comment. This model can be studied way more detailed than we will do in this video. Here we only discuss the basics and comparisons to the Rutherford model. For more details and information about the experimental basics of this model, I will link a book in the comments that I use myself. This link will lead you to the German version since I used this one. However, I also gave the English title in order for you to find it. Let's start with the Rutherford model. The basics of this model we already discussed in another video, which is linked in the description box below. Here again a short summary. The Rutherford model introduces the concept of an atomic nucleus and an electronic shell. In the nucleus is the entire positive charge and it makes up for most of the atom's mass. In the electronic shell, negatively charged, very light electrons circle the nucleus on arbitrary orbits like planets orbit around the Sun. This shell makes up for most of the atom's volume. The Bohr model is also based on an atomic nucleus and an electronic shell. Analog to the Rutherford model, most of the atom's mass and all of its positive charge are in the nucleus, while the electrons in the shell orbit the nucleus. So, what's the difference? While Rutherford suggested the electrons would move on arbitrary orbits, Bohr explained that electrons move only on certain, so-called discrete orbits. These orbits, usually called shells, only offer space for a certain number of electrons. For simplicity, we will only discuss the first three shells. This can also be seen in the figure here, an atomic nucleus and the first three shells. These shells are numbered starting at the inner one. The first shell is filled, so closed, when 2 electrons are on it. The second and third shell are closed when they are occupied by 8 electrons respectively. But how are those electrons distributed? The electrons first occupy the innermost shell. If this one is filled, the next shell will be occupied. This happens because an electron needs more energy to occupy an outer shell, so it tries to be on the innermost shell possible. If you apply energy to an electron with electromagnetic radiation, the electron can be moved to an outer shell. This process is called excitation. This shell structure you can also find in the periodic table. Also here we will only discuss the first 3 periods for simplicity reasons. In the first period are only 2 elements, hydrogen and helium. Hydrogen has 1 electron and helium has 2 electrons and therefore a closed first shell. In the second period are 8 elements, in which the second shell is then occupied step by step. Lithium from the first group has 1 electron in the second shell. Beryllium from the second group has 2 electrons in its second shell. So the shell becomes more and more occupied with each element of the period. In the third period, the third shell will then be filled. This system is a good explanation for the electronic shell in the first periods. With this in mind, we will discuss the octet rule. The elements of the 8th main group or the 18th group are called noble gases. Those elements all have a closed outer shell, which is an especially stable electron configuration. Helium has a closed first shell with 2 electrons, while all other noble gases have a closed outer shell with 8 electrons. This is why this rule is called the octet rule. Also, other particles try to get this especially stable structure by bonding to other particles or by releasing or absorbing electrons. To understand this, we will look at some monatomic ions and its corresponding atoms. Elemental lithium, for example, has 2 electrons in its first shell and 1 electron in its second shell. To fill the second shell completely, it would need to take up 7 electrons. Instead, it releases 1 electron. Then there is no electron left in the second shell, and the outer shell is the first shell, which is already closed. In total, the lithium is then singly positively charged, since it released 1 negative charge. This is also how lithium usually is found in nature, as an Li+ ion, because this electron configuration is more stable than the one from elemental lithium. Therefore, elemental lithium is very reactive, like all elements of the first group of the periodic table. All of these elements have in common that they have only 1 electron in their outer shell, which they try to release for stability reasons. Elemental magnesium has 2 electrons in its outer shell. Just like lithium, magnesium prefers to release 2 electrons, leading to its closed second shell being its outer shell. Since magnesium releases 2 electrons, it is then doubly positively charged, an Mg2 plus ion. For elemental chlorine, it is the other way around. It has 7 electrons in its outer shell and needs 1 more electron to fill its outer shell. Therefore, chlorine often takes up another electron, leading to singly negatively charged Cl- ions, which then have a closed third shell. The Bohr model introduces the principle of discrete shells, that electrons can only be on those shells and that each shell can only take up a certain number of electrons explains already the preferred forming of ions for some elements. This was a first introduction into the Bohr model. If you have questions, suggestions or tips, leave them down in the comments. If you liked the video, like it and subscribe to my channel. See you in the next one.